Good morning. Hello. Good morning. It's great to hear everybody socializing, energized for the conference. I'd like to introduce myself. I'm Tom Belovitz. I'm the interim dean here at Portland State University Library. I'd like to welcome everybody to our campus and to Online Northwest 2018. Before I get started or introduced, I'd like to thank a couple people. Stephanie Doig is on our local arrangements committee, and she's the person who really puts a lot of thought and energy into making this a great conference. I'd also like to thank Asia Bentoncourt McCarthy and Robert Mange, who are the co-chairs of the program committee, and they make this a great learning and sharing experience. And with that, I'll just turn it over to Asia and Robert. Thank you.
Thank you so much for that wonderful introduction, and thank you all for coming here today. We're really excited about this year's program and the sessions that we have prepared for you. I also want to start off with a couple of thank yous. Particularly, I'd like to thank the Online Northwest Program Planning Committee, who's put together the program for you today and have done a lot of work to make this conference happen. So could I ask the Program Planning Committee to stand? Thank you. I also want to recognize the work that the committee does here at Portland State. They do a lot of the logistical work, and without them we wouldn't have been able to have this event today. So if anyone from that group is here in the room today, can I ask them to stand? Recognized? Oh, well, I imagine that they are all working very hard. But if we could all give them a round of applause in their absence, I think that would be fantastic. And then finally, I want to thank our wonderful presenters who are here to share the work and the research that they've done, and without them, we wouldn't have this awesome program. So if I could hear a round of applause for our presenters. In addition, I just want to share a couple of kind of FAQs before we get started. On the back of your name badge, you will find Wi-Fi information, our conference hashtag, if you'd like to share about your experience on Twitter or Facebook, and then also a link to our program in PDX Scholar. Our conference materials will all be located in PDX Scholar after the conference, so if you attended a presentation or missed a presentation and you're interested in more information, you can find that there. I also want to note that there are some water bottle refill stations. There's one right outside this hallway, and then there are additional stations in other buildings, so if you've brought a water bottle, you can use those. And if you did not pick up a conference program on your way in, there are printed programs up at the front, so you can pick one up on your way out. And with that, I'd like to invite Beth Picard up here to introduce our keynote speaker.
It's a long walk. Hi, everyone. I'm Beth Pickard. I am a member of the Planning Committee. And we have an exciting program today, and I'd like to start by introducing our keynote speaker, Dr. Danielle Robinson. Dr. Robinson has done significant social justice work by helping to advance open research and to foster inclusive research communities. She has worked with libraries towards this end. Dr. Robinson has received a National Science Foundation Fellowship. She's worked as Mozilla Fellow for Science, and she currently serves as co-executive director of the nonprofit organization Code for Science and Society. And this work brings together communities and empowers them to build technology for the public good. And many of their projects focus on research and scholarship. And in this age of insecure data creation and access, they work directly with librarians, researchers, and institutions to improve research reproducibility, research data management, and data preservation. So please help me welcome Co-Executive Director of Code for Science and Society, Dr. Danielle Robinson.
It is a long walk. Okay. Thank you, everyone. I'm so excited to be here. And special thanks to the organizing committee for inviting me to speak. I'm based in Portland, and I love working with the local open scholarship community here, so it's super fun to be here. Today I'm going to talk about decentralization and hopefully get you a little bit excited about the potential of decentralized approaches to change the way we work online and interact with scholarship and each other. So I'm going to talk about a project we've done in collaboration with, sorry, microphones are weird. I'm just going to hold it. I'm just going to hold it like this is karaoke. This is better. Okay. I'm going to talk about a project that we did in collaboration with California Digital Library that was funded by the Gordon and Betty Moore Foundation, along with a project called the DAT Project, which is one of our sponsored projects. All right. So I wanted to talk a little bit about myself first, like why am I here? Why should you be interested in what I have to say? As the kind introduction stated, I'm based in Portland. I did my PhD at OHSU in neuroscience, and I finished that in 2016. And during that time, I got really involved in open scholarship, open data, trying to make the academic and scholarly enterprise more accessible to more people broadly. And so I wanted to throw up this picture because this is an event that I did along with the OHSU Library. Robin Champeau, who kindly reviewed the slides for this talk, thank you, Robin, is in the middle. And this was an event that we did along with Mozilla Science Lab that brought people from Oregon State, UCSF, PSU, OHSU, and Centralia College all together to work on open projects for scholarship. So some of these were code projects, some of these were community projects. The Alliance for Visible Diversity in Science, based at OHSU, is up there. And I just wanted to throw this up to underscore that for me, I said this at dinner last night, like the software stuff can be really a lot easier than the people stuff. And so people are really what power the changes that we want to see in society, and people bring their own information and biases to the software that they write. So we try to bring people together and give them the skills and the support that they need to build amazing tools that will improve society. So let's think about modern research for a minute. So transparency is critical to modern research, but for a researcher who has a lot of different incentives and pressures, this is going to look different for different researchers. Researchers produce a lot of data, and their funders may want them to deposit it openly. They have a lot of options now to share that data online, but they also have a lot of pressures on their time and pressures on their attention. So there are more options than ever before for people to share data and make it accessible, but that looks, how those are used are different in different disciplines. And so, 10 years ago, maybe if you needed to share your data online, you would have done something like this. You would have made what I'm going to call a sad directory. And this, no offense to NOAA, this is an awesome directory. This is still very frequently updated. But so wet data, if you're going to put them online and try to make them accessible to a broad audience, you're going to use the infrastructure that you have. And so 10 years ago, this would look like a directory. Right now, there are a lot more options. So this is a really cool data set that y'all should spend time exploring. This is made by the Center for Watershed Sciences. Center for Watershed Sciences at UC Davis. And so there are less sad directories today because people want to put their data up in a way that can be interacted with and explored, and really tells the story of the research, not just like, here's a bunch of raw data with no documentation. So, but not everyone has the time, bandwidth, or skill set to make, or budget, frankly, to make something like this. So for a lot of researchers, what they'll do is check out what the library says, because the library is experts in giving advice on this topic. So this is pulled from OHSU's library, and here we can see that they're suggesting 3 options, and there are, as many of you know, way more than 3 options. But I didn't want to pull up PLOS's list of acceptable repositories that's like multiple pages and broken down into sections. So the 3 options broadly are an institutional repository, a private repository, that's Figshare, and a nonprofit repository. And most of the options for where data are stored fall into one of those 3 categories. So what does that give us? That gives us silos of information, and it is hard to move between silos of information. Once data are deposited, they'll be in a trusted repository, and there are new problems that arise from this. So the library is tasked with working across silos, helping researchers understand what are the advantages of each option, what are the drawbacks of certain options, and which is the best for their content. And so librarians need to make a recommendation for, what's the best place for you to steward this for the rest of time so we can preserve all of human knowledge for the long haul. And I don't think working across silos is always hard, sometimes harder than it needs to be. You can do this through collaboration or pull from someone's API, but it's not, I'm going to argue that it's not sustainable. And is this where we want to be? We can continue making these silos bigger. But as they get bigger, they become increasingly expensive and difficult to manage and only reasonable for very large, often for-profit companies to run. So is this going to be sustainable? I'm not sure. And I think that the concept of silos and storing data in centralized repositories comes from the way that the web was constructed originally and the way that we usually use the web right now. And I don't think it's sustainable, so I want to talk about what's next. What are we going to do? So, as you all know, I'm the co-executive director of Code for Science and Society. We have a mission to empower communities to work across domains to solve problems with innovative software approaches. We do a lot of work with decentralized computing, and the DAT project is a peer-to-peer data sharing protocol, and that's one of the projects that we support. So we believe that technology is imbued with the values and biases of its creators, and we try to improve ourselves, so to make ourselves more better stewards and better creators of technology, and challenge assumptions of what tech is and what it should do. And so that's one of our projects, and this is what I'll be discussing today. We work across domains. So we work in research and scholarship, and those are most of the projects I'll be talking about today, but we also work for data are everywhere, right? Every industry is now creating more and more data. We work with government data, journalism. We work with people who are creating new ways of interacting online, new social media platforms. And so across industries, what we're seeing is that there is an increasing volume of data being collected in every industry, and its value is shifting. Does it have research value? Does it have business value? Does it have both? Does it have scholarly value? And as we've all seen with large-scale data breaches, everyone wants our data. And how these data should be cared for and stewarded in the long term is shifting and up for discussion in many industries. So in that landscape, libraries and technologists in the open community are trying to set up systems that will sustain humanity's growing base of knowledge and data for the long haul. So what's that going to look like? So I'll present an idea today. I'm going to start by talking about where data are today. They're on the web. We interact with them on the web, we access them through the web, we download them through the web. And I want to unpack some assumptions around the way that data are interacted with online. I'm then going to try to get you all excited about decentralization and present a vision for decentralized data preservation. And then finally, let's return to the big picture. How can we reimagine the web so that it is what we want it to be and it's not just this annoying thing that's full of trolls that we're all stuck with? So, data, they're online. And when I say data, I mean digital objects. These could be images. These do not need to be scientific data. It could be books. Essentially, everything is, all scholarly objects are at this point, not all, I shouldn't say that because you all know better than I do, but many scholarly objects are now data. So, and across domains, data live online. And this could be the early works of a writer, or government data, or newspaper archives, your family photos, all the data that Facebook took about your phone and who you've been calling, as well as scientific and scholarly data. And because data live online, data are impacted by all of the problems that happen to things that live online, namely the web is not designed for long-term preservation. And so this was underscored for many of us during DataRescue. In late 2016, DataRescue was initiated after the Trump election, when people were concerned that open government data that had been stored online, freely accessible, might be taken down or changed, or that those initiatives might be rolled back. And so there was a real fear that resources would go offline. And so suddenly federal data were at risk, and myself and others across the community mobilized to try to understand the problem and address it. Approaches and workflows of groups were different. There were many different groups across the country. But essentially, we all wanted to understand it better and try to collect critical data and figure out ways to preserve it for the long term. And all of the data were online. And Amy Harmon, the author here, really got it right. The issue was generally not that the data were being deleted, but more that the data were inaccessible. And so why is that? It's because essentially if data are linked online and listed in a directory with a link, if you lose that link, the data are essentially inaccessible at that point. So if the data were often, we would go to a link and the data would be not there, or they would have moved, or there was a PDF where a CSV should be, or the data were otherwise poorly documented. So one of the first things that our group did, members of my team worked on mirroring a copy of data.gov. If you're not familiar with data.gov, it's essentially the phone book for federal data. So Project Open Data mandates that data that fit certain criteria are listed so you can find them. And in 2016, data.gov had never been backed up or mirrored. So we worked with California Digital Library to make a copy of data.gov, so at least there was that one snapshot in time. It was pretty big. It was a lot of metadata. But now it lives on, I think it's datamirror.org, or the link is in there. You can look at the link. And you can explore it. And that's a snapshot of what it was in, I think, late December of 2016. And we made that mirror with CDL because, as Lori Allen says, the internet is a terribly unstable way to keep information available. If there's no backup of data.gov, if there's no transparent change log of how data.gov has changed, and you remove, say, all the White House visitor logs, which they did, then that information is gone unless the Wayback Machine went and took a snapshot. But that's a snapshot. That's not real version control. That's not who changed what and when they changed it. So this is my kind of tacky shout out to Lori Allen and Bethany Wiggins and Margaret and all of the other people at the Penn Libraries team. They did critical community work and complicated technical work and really intense community organizing in the middle of a complicated and fast-moving situation. So those people are rock stars. So Lori's telling us, and I believe her, that the internet is a terribly unstable way to keep information available. Why is that? So federal data, this is something from one of the DataRescue talks. Federal data are essentially equal to web pages. And that is true. Federal data can be embedded in HTML, videos can be embedded in HTML, or like we saw that directory earlier, they can just be a directory of files online that you have to click through. And so how did we get with that system? It's not designed for data preservation. It's very easy to change and move things without telling anyone what you changed or moved. And we have workarounds, but why did we get there? So to find any object online, you need to do a couple things with today's system. You need to discover the link, so you either know it or you find it. And then that link needs to work, which means that the server that the link links to is still there, and it can go down the chain and find whatever the link links to. And then when you get to the end of the link and it resolves a page, you need to trust that the information at the end of that has not been changed by anyone. And there are no assurances that that's the case. So for example, this nasa.gov link, nasa.gov is the server. We're expecting it to go through find the My Dataset directory, find the final version directory, find the pub data CSV, And then we assume that nobody has changed the pub data CSV. And so there are a lot of steps here that can go wrong. And we are essentially keeping track of data based on its location, not anything about the data, if that makes sense. So if pubdata.csv has been altered in some way, then you would hope that that would be logged somewhere in a README, but maybe not. It's not necessarily so. And so what DataRescue did essentially was test Project Open Data. This is a launch Project Open Data from 2013. I'm sorry, you probably can't see the date, but trust me, it is. And so 3 years later, we had a big test. How's it working? We need to find all that stuff and make sure it's not being changed or taken offline. And thank you, Obama. Also, thank you, Phil Ashlock, who works on Project Open Data. Was Project Open Data working? Yes and no. It surfaces links, and that's critical. It's like a phone book, but it can't guarantee that those links work. And if it can't guarantee that they're online and that they're what they should be and that they haven't been changed or altered. And when it does work, you can probably guess what I'm going to say here. When it does work, it's due to diligent data management practices from the creator to this stewarding agency and on down the chain. And when it doesn't work, it's due to the way the web works by identifying information based on its location, and it's due to poor data management practices. So the web as a data archive, examples of this problem can still be found online today. Spoiler, we didn't rescue all the data. Sorry. Examples of this can still be found online today. You can go to Project Open Data's dashboard and pull up NASA, and now they do these cool crawls where they check data quality. But unfortunately, and I don't know if you can see this, do I have a pointer that works? No. So I'll point with my finger. 9.5% of these NASA links have working downloads. That's kind of low. What does that mean? So when you click on, what does that mean? It shows you that there are many different reasons why a download could fail. Sometimes it's that there's a PDF where there should be a CSV. Sometimes it's that the link just 404 is totally broken. Other times it's a redirect or something else. But essentially what it means is that the website changed. And when the website changes, the locations of things change, and then the idea of tracking data based on their location starts to make less and less sense. And I want to take a moment to shout out to the 1 out of 9,128 data sets that specified a license. Right there. Just one. Thank you to that person. So if all data are online, all scholarly data, government data, all of BuzzFeed's archives, they are all susceptible to the problems of all online content, namely link rot and content drift. Link rot is when links failed, and we saw lots of examples of why that can happen. There are many different reasons why that can happen. Content drift is more nefarious, because content drift is when contents or data are changed, and it's not, the web does not require you to say that you changed anything. And so you can go to a link and there's stuff there, but it may not be the same stuff. It may be an updated study, it may be an older version of a study, or it may be something else entirely. Together, these two are called reference rot, and I read a bunch of papers that I have linked at the end of this presentation, which will be available online, so you can look at all my links. So things are a lot better now. But this is still an issue, and I'm going to look at my notes here, in journalism, legal scholarship, social sciences, digital humanities, biomedical research. Essentially every discipline has problems with reference rot. And it's a lot better now than it used to be because of groups like Crossref and wide adoption of DOIs, but the problem is not solved. And so essentially the problem we face in DataRescue and the problem that scholarship faces in general is that the web is not designed for long-term preservation of anything. In fact, unfortunately, I think that the internet is broken. And we're using it to store and access and distribute all of human knowledge. Oh no. The web is dominated by centralized, non-interoperable entities that want to own your data and then repackage it and sell it to other people or back to you. Now, I could be talking about Facebook or scholarly publishing. It's the same problem. So what are we going to do about that? How did we get here? I don't know. The internet's kind of new, though, so the good news is we haven't, in the scope of human history, we can change this. We can do whatever we want. So the systems we use today are a direct result of the incentives for centralization that came about in the early web. So the early web, and I encourage you to read about ARPANET, and it's very cool. I need to do more reading about it. But the early web was distributed, similar, almost decentralized, but built by the DoD and other entities that wanted to have top-down control. And pretty quickly, it became beneficial and good for business to centralize. When you have a silo, you know what's in your silo, you can manage it, you can monetize it, you're in control of it. It is a system that makes sense, especially if you are trying to make money. So web centralization has had a big impact on the way we use the web every day for our social, communication, and scholarly uses, and the way it's used in every industry. We trust a server to locate objects, not to change them, and because a server only knows what it contains, silos are the natural state, and data may be replicated across multiple silos that don't know about those other copies of the data. For example, Netflix and Hulu are two centralized services that many of you probably use today. You can log on to Netflix, ask Netflix what it has, and it will tell you. You cannot ask Netflix what Hulu has. Netflix doesn't know, or if they know, they're not going to tell you. So it's hard to search across silos. Today's web relies upon URLs to identify objects based on their location. It depends upon the ability to change information without needing to change the URL. If a newspaper article needed to change its URL every time it was updated, that would be very hard to manage for them. And it also depends on aggregating content, so creating a silo, knowing what's in your silo, managing what's in your silo, to improve discovery. So, some features that are missing from today's web. Persistent identifiers. So identifiers for data that track changes, but don't change, that's not what I meant to say. Persistent identifiers that allow you to track data as it may change, but are not based on the location of the data, or instead based on the identity of the data. It also is lacking a transparent change log, and it's lacking links between silos, so it's still very hard to work across silos. So today there are, linking information to make it more findable, more accessible, more interoperable. If you're working between silos, there are workarounds to do this. You can directly collaborate. You can go to one data repository and ask it what it has, and then go to another one and ask it, or you can use APIs. But fundamentally, even if a link is created, you're not going to have content verification. There's no way to say, oh yes, this is the verified copy, this is the original author copy, and this is a verified copy of that copy versus this is not a verified copy. So I want you all to imagine what would the use of the web look like in scholarship if you were in charge of what it would look like. So today, the web is being reimagined. A lot of people think that the internet is broken, the way we use it is not the way, we should imagine a new way. And so the ideas that I'm interested in are the web as a network of creators that freely distribute content and share it, with version control, with persistent identifiers, and without centralized control, or with less centralized control. We have an opportunity today to step back and ask what we want the web to do for us and try to make it real. Technology is changing, and we can step back and look at the assumptions and values that are baked into the web as we use it today and ask if those are the values that we want. So what's important to you? Is it to limit the monetization of scholarly work? Is it to make preservation easy? Is it to link institutions to expand access to data across, every institution? Is it to not even link, just establish trust between different institutions? Is it just removing barriers to access? So when I ask myself that question, what's important to me? My answer is that I want to remove all barriers to access, and I want to make institutions trust each other, maybe stop arguing about standards, and link them so that OHSU can see what data PSU are storing, and PSU and OHSU can see what's in Figshare, and all these things are linked together. But some of the things that make that hard today, that make access hard, that make it still possible that articles about open access can be behind paywalls, have to do with the way the web was created and the values that the current web prioritizes. The current web prioritizes money. If you have money, you get access. And that's not how I want it to be. So let's examine some assumptions. I'm going to talk about assumptions around data preservation and how they came to be. And I want to pick out 3 ones that I think are important to consider. The first is that preservation will be initiated by the creators of data or scholarship. The second is that centralized storage is stable. And the third is that preservation requires custody or ownership. So all data and scholarship comes from somewhere, and this is my ode to data in drawers. This is my PhD dissertation data as I left it 2 years ago. Hi guys, how's it going? Much of that data are still in the drawer. Some of those data relate to works that are not published, and my PhD advisor doesn't want to release data before the work is published. And I get that. He's under lots of different pressures, and that's just how science is. Ideally, what would happen with these data in the drawer is that I would work with Robin or Letitia or another librarian at OHSU, pick the best place for the parts of it that I think are going to save some other poor grad student 2 years of pain. And then I would make that freely available. I would say, this needs to be preserved. That's usually the first step. And for a bunch of really valid reasons, that should be the first step. Because if a library is tasked with preserving every piece of data that every scholar at that institution creates, that doesn't sound very realistic. And that sounds really hard to manage. And libraries have limited human time for curation and maintenance, and also limited storage, money for storage. That doesn't make sense. So we will want the researchers to tell us what's important for the field, what needs to be preserved. But that doesn't always happen. And so this is my friend Tian. He has kindly let me use this amazing picture of him for this slide. He is a cognitive neuroscientist, and he's working on a paper which includes, writing code, transforming data sets, and writing words. And he's going back and forth between his lab server, and the data steward over there has no idea what he's doing. And when I say data steward, I mean any data stewarding entity. This could be a repository or a library, anything. So Tian is not going to save this until he decides it's done. And he'll deposit a final version, maybe, because not everyone does. And so I think what's interesting here is that we miss preserving raw data and versions of data, which can be critical for reproducibility. And that's just the way our current system is. Danielle Lowenberg wrote this great piece called, I think it's We Are Talking Loudly and No One Is Listening, about research data management. And she said, sharing data is not well understood, not incentivized, and not accessible for researchers. And I added, and preserving, because I think it's kind of the same thing. And I think this is important because researchers don't understand it, and researchers can't prioritize it the way that we would want them to. And we can't assume that Tian is going to understand the value of his early work, not because he doesn't care about it, but because scholars tend to not understand the value of their early work. They value the thing that's done and published. So it's important to think about how we can help people understand and incentivize, and understand this work and incentivize it. So let's say Tion's going to deposit his data in a data repository. The next assumption is that that's the best place for it. A solid, well-managed data silo is where data should go, because that really kind of is the best option that we have today. So when data are given to a trusted entity for storage, we assume a couple things. Is it stable? Do we trust their financial stability? Do we trust that they're not going to act on the business opportunity of selling us back our information down the road? Do we trust their continued commitment to open access? Centralized storage is really hard to scale. And because researchers are still not depositing all of their data, I don't think we have fully hit the full problem of scale. And also, what you get when you do start reaching the problems of scale is you get single point of failure, privacy decisions get made unilaterally, and you get all the problems of your favorite centralized platforms in other industries, except in our world. And so I think none of the data repositories that we tend to use today have really been around long enough or are really dealing with large enough volumes of data for us to run into these problems, but they are coming. And I think, unfortunately, this is not the future that I imagined. Scholarship is another form of online content creation today. Sorry. I know that I did not like to think of it this way when I was a researcher, so I imagine y'all probably don't like to think of it this way either. But our work is used by for-profit entities to drive clicks, drive advertising dollars, grow subscribers, and sustain their businesses. So that puts us like right solidly there with journalists and anyone else who's creating stuff that lives online today. So hence the money bags and the Shruggy, because it's what we got to use it. When researchers or scholars of any kind give up custody of their work or even the rights to their work, they risk it being repackaged and sold back. And you've all seen that happening. Reducing reliance on centralized systems can help return the control of those scholarly assets to the creators and trusted scholarly entities. So, yeah, sorry. The third assumption that I want to unpack is that preservation requires custody. In the very old days, preservation literally required custody because you had to own the object and keep it safe and that, I don't want to imply that that doesn't happen anymore because it still happens. But for digital objects, the idea that preservation requires custody is kind of a fallacy. In order to preserve data, an entity that is centralized needs to own it. So I can only control what's in my silo in a centralized system. Ideally, the centralized model requires custody in order to provide access. Ideally, even in a centralized system, we were all hopefully in agreement that our amazing scholar here should be able to access any data that she wants to access on her laptop in the park. No big deal. She doesn't have any paywalls. She's living the best life. And so the question is, if the expected access is online, is ownership and custody of the information necessary? Can we replace custody with access? Is knowing where the data are, plus trusting the entity that is providing them, better than ownership? And I think that it is. And also, I think we reduce the burden on any one institution to own everything with a mandate to know where it is, and that will make things more sustainable for all. So this is not a new idea. Stephen Abrams, a frequent collaborator of ours at California Digital Library, gave this talk earlier at Pitapalooza and wrote a paper in 2008, which was now like 10 years ago, about the idea of preserving in place, bringing preservation services to the content, rather than trying to scoop up everything and own it. I think we're all on the same page on fair data standards, right? We need data to be findable, accessible, reusable, interoperable. But there are key holes in the findability and accessibility parts that I think we can plug by linking existing silos. Do you like that picture? That was hard to find, a picture of silos with a literal bridge between them. Thank you, Flickr Flickr Creative Commons licensed image creators. So, but we want to leverage the existing infrastructure to make data more findable, make them more accessible, and make them more interoperable. So we want to do this by linking trusted institutions. I'm not interested in creating a new unified platform, building a new island that you all need to come to. What we like to do is build what we call foundational technology. It's not going to require you to develop new systems in your institution, but is instead going to share metadata. Love sharing metadata, it's so fun. So we want to, support researcher practices. We don't want to make more work for researchers or librarians. We want to make it easier for everyone. And there are new technologies today that can link data silos and build trust in a network. Now, I think it's key that libraries are the key foundational dots in the network, because libraries and librarians are the people who spend the most time thinking, not about how to improve shareholder value, but how to steward all of human knowledge. So. That is one of the main reasons I'm here. So in a decentralized network of trusted institutions, if they're linked at a foundational level, they can share information about their collections, make copies of assets that are at risk, make copies of assets that are frequently used, and quite literally support each other. So visions are nice, but let's talk about the caterpillar part. Let's talk about what's really involved. How would a system like this be built? And now we're at the point in the talk where I'm going to talk about decentralization, what it is, and why it's interesting. So we've been over the centralized hub and spoke model. In decentralized models, rather than identifying content based on a location, content are persistently identified, and because it's a network, instead of needing to add more storage capacity to the silo, each node that joins the network adds storage capacity, and the network can scale. So there are multiple decentralized approaches. You have probably all heard of blockchain. I am not going to talk about blockchain. Blockchain is often is related to Bitcoin, and so it's getting a lot of play these days. Peer-to-peer technology is associated sometimes with piracy, because if you were around in the early 2000s, you may have been downloading copyrighted material. It's also blamed for the death of Blockbuster. Well, that's okay. So the tech I want to talk about is peer-to-peer. We're going to say goodbye to blockchain for now. But at the bottom of this slide, I've linked to an ALA article about blockchain for libraries, if you want to think more about that, and a blockchain explainer written by our lead developer, Matthias, that I find really useful. So at DAT, we think of ourselves as building peer-to-peer public technology. What that means, peer-to-peer public technology, the tech has applications way beyond just me downloading an HBO show. Peer-to-peer tools are powerful data transfer mechanisms with better guarantees for data integrity and ownership across multiple computers. So you may have a vague idea of how this works. I will describe it. If the dog has genomic data on his laptop and he would like to share it with this network of cats, he can check the information, excuse me, I need a little drink of water. The dog can share the information with the cats, and the cats all sync with his file automatically without the lengthy upload and download to a central server. Peer-to-peer can also operate between two computers, and that's kind of similar to the idea of the current web, where there's a server or a client and server model, but it doesn't need to. It can work across a larger network. So at the DAT project, we're a nonprofit-backed, open-source, peer-to-peer file sharing protocol. And what that means, in more simple terms, is that when you want to track a folder with DAT, DAT creates a persistent identifier that travels with that folder, and you can share that across a network of peers. So there's more to it about how the network works and how version control happens within DAT, but it's kind of similar to things like Git or other systems for collaboration that you've used before. So is everyone on board with that? You can ask questions about it later. When you have a persistent identifier, you can use that to track that package of data as you share it from your computer, and other entities copy it, and there's better control of ownership. And there can be any kind of data in the package. So why is that interesting for scholarly data? It's interesting because it helps automate preservation. You can automate backing up. You can find data regardless of storage location, spread the bandwidth and storage across a network, and build foundational links between silos using this technology. So right now, data is being used by all kinds of things, and I'm not going to go through them because I just looked at the time and I'm a little bit running behind time. But my slides will be shared and you can link out. There are a lot of people building on DAT. Most of them are, we're building data tools, other people are building new social media applications, ways for artists to share content, and ways for scientists and scholars to interact. So for more on DAT, you can check out our white paper, or if you want to play around with it, we have a tutorial at trydat.com. So, to review, peer-to-peer provides a model and a new framework for how institutions collect, preserve, and share data. One that prioritizes access, prioritizes linking institutions to each other, and importantly, does not require a new platform or big changes in workflows. To step back a minute, data preservation and access are all about trust, and I trust libraries. So I'm going to move along. I was going to say more emotional things about libraries, but you all know that I love you because that's why I'm here. So let's talk about how are we going to build this thing. We're working with California Digital Library and UC system researchers to prototype, and we start at the point of data creation. So this is our team with Denise Ruiz-Ramos, and she's describing the CSAR gene annotation pipeline. What we learned from working with her is where can we automate backing up her data? Where can we automate moving copies of her data from the lab server to the library or another data preservation entity? How can we link researchers to the library, and then how can we link libraries to each other? So Tion here, we've already been through this. He's going to deposit one copy at the data steward maybe if he wants to. But if he's running DAT on his server, then the data steward can see what he's doing and can see that other researchers are using his raw data. They're downloading it. They want it. It's a useful resource. Data steward can decide to take a copy. Now, if this is connected to multiple places across the network, Tion's lab server can catch fire, or Tion can close his lab, and the data are safe because they're stored across the network. Now, this also works between multiple institutions. So Sarah here has questions about Tion's work, and she can download a copy, or she can ask her institution to collect a copy, so it's there mirrored across the network for other people to use. Another model, and this is the preservation in place part, so Amel and Maria work on a large genomic data set that's used by the community, but it's really big. So the Blue institution does not have the bandwidth to take a copy. But Sarah, again, wants to reuse their raw data, replicate their work. She can collect a copy personally, or she can ask the library to host a copy if it's a scholarly resource that a lot of people want access to. So in a decentralized model, every institution or entity contributes bandwidth, metadata on their collection, and a commitment to preserve what they own. And every user can access information on collections across multiple libraries and data stewards, the history of objects, and whole or partial data sets from the network. So how can we get there from here? Where are we now, and where are we going? One thing that the DAT in the Lab project has taught us is that we cover more ground working together. This is us at UC Davis, talking to researchers and librarians about how they work with data, what their workflows are, and how we can insert our technology in a way that doesn't change the way they do their work. And so I want to close by saying that now's the time to reimagine the web, and just remind you that whenever technology gets built, and this is not my idea or a new idea, this isn't even Stephen's idea. The creators of that technology bring their values to it, whether they are aware of it or not. And this is something Stephen pointed out. He works on digital democracy, which is an amazing project about indigenous land rights in South America. And so they use parts of DAT to help that technology work offline so people can have access to the rights for the land that they own. So, and I encourage you to check out our community call link, that's at the bottom. You can read more about his work there. But it's important to think about this when we talk about what we're gonna build, right? The web that we use today was designed, 50 years ago, and then quickly monetized, dominated by for-profit companies. And this web assumes a lot. It values, people who have good internet connections and can pay for those. It values people who have money for subscriptions. It basically values money. I guess I should just say that. And so I think I want to close by inviting you all to imagine, what would you like the web to do? What's important to you? How do you think that we can build a web that supports the things that are important to you and important to the future of scholarship? We're in a situation where we can reimagine what scholarship is. Is it just online content creation? Well, if it is, then I can't remember the journal now, but that journal that flipped from being an Elsevier journal to being a privately run journal, they probably have the right idea. If it's just online content creation, let's own the creation of the content. We can reimagine how scholarly resources are found to make them more accessible. We can reimagine how institutions are connected now and how they should be connected and how preservation happens. So I invite you to reimagine scholarly data preservation with us. We are going to be hosting a really cool fellowship sponsored by Ford and Mozilla, and the link is in there. Applications close on April 20th. It's a 10-month paid fellowship with money for childcare and health insurance. Not actual health insurance, just money for health insurance. That's another talk. So thank you. That's the end of my talk, and 54 minutes, I can take questions. And thank you again, everyone, for your kind attention, and thank you to the organizing committee for asking me to speak.
So if you have questions, raise your hand and I can bring that mic around.
And I will stand like, I don't know, the Pope or something at this balcony.
Sounds like it worked. Well, it did. Can you hear me?
I can hear you.
Sweet. So it seemed pretty clear from your presentation how this DAT project affects storage or preservation. Could you talk a little bit more about findability of this information within this project?
Yeah, sure. So what DAT does when you check a file in, or let's say, start tracking a folder with DAT. If you've used Git, it's kind of similar to that. So you create a folder of metadata that live inside the package of information that you want to track. It doesn't change the contents of the file or anything, but what it does is make that, if you share it, it makes it discoverable by the network. If you don't share it, it does nothing. So essentially, content are securely hashed. So, I shouldn't say hashed. I was going to avoid saying hashed because then I have to explain Merkle trees, and I don't even know if I can explain Merkle trees. So essentially, content have persistent identifiers that are unrelated to their location, and these persistent identifiers are how you find content across the network. So it makes it brings in a new system for discovery, but also it doesn't necessarily exclude the option of using existing metadata schemas on top of it. It doesn't require anything. It's a protocol. So it's very it can be used on any type of file. So once you have something in the DAT network, if you know the persistent identifier, you can, and it's online, hosted somewhere, you can just go get it. If you don't know the persistent identifier, what we're working on in our prototype project is how to make those persistent identifiers discoverable so that, let's say, imagine that someone who's interested in adding new objects to a data repository can only see the objects that are being downloaded the most frequently and then make curation decisions based on the use of the objects. Does that make sense? Does that make sense? Okay, cool.
I think we have time for one more.
I'll be here all day, though. I'm happy.
Hi, I'm from the University of California, Berkeley, and talk about silos. I was excited to learn about many things I didn't know was happening in my university. My question is kind of related to library collections. Like, one path I see us taking is that we're sort of incentivized to build these silos to kind of represent our institution and sort of say, what we used to say is like, look what we have in print, and now we say like, look what we have digitally that makes us unique, that kind of gets our alumni community excited, and as things go away, there's been really a lot of pushback transferring kind of collections money to other projects. So I'm kind of curious how you see the library side working, either in terms of personnel or funding or just anything to like kind of go more in this model instead of like everything being internal to sort of bump up your own institution.
Yeah, I think that, so when we work with CDL, and I'd love to talk to you more about what's happening at Berkeley, but in our work with CDL, what we've identified is that libraries have limited bandwidth, forever storage is really expensive, so we're hoping, well, our collaboration with CDL is also with the Internet Archive, which has money and storage. So we're hoping to, I think the idea is that each institution, instead of creating a silo and putting all of the scholarship that comes out of the institution into their silo, can make choices to put some stuff in the silo, but then also just link out to where other things are. And so the burden of curation doesn't really go away, and decisions about what each institution needs to steward long-term still need to be made, but they can be made in the context of knowing, okay, this data set is, that Pisces, that fish data set from UC Davis, maybe it's being used by a community, but it's not as much well used as it was, and the Internet Archive has a copy of it, so maybe UC Davis doesn't need to keep its copy forever if it's mirrored in enough places in the network. Does that make sense? Yes. Yeah, I'd love to talk more about what's going on in the UC system, though. We have great collaborators there.
So I want to say thank you again to Dr. Danielle Robinson for this wonderful keynote.